Hi there, this is Jacob Nash, and in this video, we'll be talking about moments and center of mass. So there's a lot of physics behind this. You might know what moments are or center of mass. You might know. I'm not going to really explain that in this video because that's not really the purpose of this calculus concept. But we are going to just look at how to do these calculations. And so basically, the three types of things that you're going to need to calculate are, well, you might need to find my, mx, little m. So it's really five things. X bar and y bar. Those are the five things for these types of questions that you'll see. Now, what the heck do they mean? Well, my and mx, they're going to be the total moments and in whatever direction that you see. So y or x. This little m is going to be the total mass. So uppercase M represents moment, lowercase m represents mass. That's something to be careful of. It's kind of hard for me personally to draw lowercase m versus uppercase because they kind of look the same the way I draw it. So I'll try to be careful about that. But these are uppercase m's and then that's lowercase m. Now the X bar and Y bar, they are going to be coordinates. So you'll usually see them as an ordered pair like that. And that's for the center of mass. So those are the different things that you'll have to calculate, and they're not actually that hard calculations. So this is not a very hard concept. Um, Now there's two different types of questions that we're going to look at. The second is more common, but you still might see the first. Now the first type is if you're given points. The second type is if you're given functions. So this is if you're given points, and it's definitely easier. But like I said, it's not as common to see, but you might still see it. So let's just refer to where you see number one right here. Let's look at this question right here. Let's say they're like telling you, find mx, which is only what they would because this is in the x direction. You wouldn't, my doesn't exist for that. So how would you do it? You would say 14 times -3 plus 16 times 2 plus 22 times 8. It is just simply the mass, sum of the mass times whatever value that you see. So number one would be a really easy question. Number two, now we have still three masses, but we have three different points. Now, if we're trying to find my or mx, it will change. Now, there's a mistake on this thing. It's actually supposed to be mk, xk. And if you know by now, anytime you see these things like that are basically just sums, you see all these random letters and it might confuse you, but you should know by now that the K is just really a counter and we've used that as I before. It doesn't even matter really. Um, it's just telling you like the sum of the M times X, M times Y. So if you're trying to find mx, you use the y coordinates. And if you're trying to find my, you use the x coordinates. So that's something to be careful of. It's backwards of what you think. But for this number two down here, which I hope it's not cut off for you, but you would, if you're trying to find mx, you would do 4 times -5, 3 times 1, 3 times 5. You would add all of those together. Once again, if it's mx, we use the y values. And y, we would do 4 times 2 plus 3 times -3 plus 3 times 3. So that's an important thing. That's the first type of question that you would see. Not that hard, right? And the second type of question that you'll see is more common, and it's a little bit harder, but not much harder. Um, we'll come back to that. So this is the second type of question that you'll see where, hey, now we don't have points, we only have functions that are bounded. It almost looks like a disk washer or shell method question almost. So still remember those old things that we knew from those days when we were learning about that. So find the centroid of the region in the first quadrant bounded by e to the x, x equals 2 and both the axes. Well, it's redundant if you think about it because it says first quadrant and then it says that. But that doesn't. So anyways, you would always want to draw it so we know what e the x looks like. It intersects at 1 right there, and then this is the x equals 2 line, and then this is the region. It's what this question is saying is find the freaking center of that thing. That's all it means. It says centroid. All that means is the center of this thing. So how do we do that? Well, that means that our answer is going to need to be a coordinate, which is x bar, y bar, and x bar equals my over little m, and y bar equals mx over little m. Keep in mind, once again, it's the opposite letters of what you would think. Use the my for x, use the mx for y. The numerators are saying what we just did in the last slide. What is the total moment? The denominator is what is the mass. And my and mx are not going to be found the same way as in the last question because we have functions. So instead, as I mentioned, how we would go back to that other slide that I skipped, there are formulas to find my and mx. Um, and the formula to find my is just this, only this numerator right here. Density, which that looks like a letter P, it's not actually, it's just a Greek letter. Uh, Density times the integral of x times the function. That's how you find my. How do you find mx? It's instead the same thing, but 1/2 times the function squared. And then as you can see, to find the total mass, we just do density times the function and we don't do anything to it. So once again, for my, x times the function. For mx, 1/2 times function squared. For just the mass, total mass, just the function. And all of them are multiplied by density. If you notice, the densities are in the numerator and denominator, so they'll end up canceling out. So you don't have to know them for x bar and y bar, but you would for the individual calculations. So that's something you might think, and then it's pointless if they cancel out. Well, it is for finding the centroid, but if you wanted to know just my, just mx, or just m, you would need to know the density. So keep that in mind. So let's go back to the question now. Okay, so the first thing that you need to do is, I mean, you don't have to do it in a certain order, but you need to find my, mx, and little m. So we find my first. All you do is density times the integral of x times function. How do we get that 0 to 2? Because that's where the region goes from. That's obvious if you sketch it, so that's why it's good to sketch it. So, dang, there we go. Now that is x e the x. Oh, great. How do we integrate that? Integration by parts. So, yeah, you can't forget about those things just because we're on a new topic, sadly. Or not even really sadly, but uh, hopefully remember it's uv times integral v du. So u is going to be x. How come? Because you always make u the thing that will have a derivative that's better. And it's better because du is just 1. The derivative of x is just 1. That's good. That makes it simpler. And then dv is just e to the x. And then obviously du is dx. V is e to the x, because the antiderivative of e to the x is just e to the x. So you plug that in the formula, you have x e x e x, like just like that. Now we can do the integral of this, which is just e to the x, and then when you plug in 0 to 2, this is what you would get as your answer. P, or not P, I'm used to saying that. It's really rho, I think, rho. Sorry, I'm not very good with my Greek letters, but uh, times e squared plus 1. Now, mx, same thing, but this time 1/2 times function squared. Oh, yay, now we don't have to do some stupid integration by parts. Instead, it's just a u sub thing, and you would get this 1/4 e to the 2x, and then when you plug in 0 and 2, you get this. Now we also have to find little m, which is just going to be, once again, density times, it will be 0 to 2 of the function, which is e to the x dx. So that's going to be density times e squared minus 1. So now, if we're trying to find my and mx, or if we're trying to find x bar and y bar, you do my divided by m, which this is my divided by m, which is up here, and then the other thing will be mx divided by same thing. And that's your answer. So that's not so bad, right? All you have to do is just find mx, my, and little m, and then you can find centroid. Um, Now let's look at another question. This one is just exact same process, so I'm going to go through it a little quicker. The only difference is that, as you can see, that it's the area between two curves, so you do top curve minus bottom curve. So if we're trying to find my, it's still x times the function, but we have two functions, and you subtract them to find the area in between curves. Remember, it's the top curve minus the bottom curve. So x times square root of x, x times x squared. Luckily, when you do the integrals of these, it's simpler than the last one. And the work isn't shown like what answer you would get, but as you can see, you would just add these exponents, 1 plus 1/2, etc. And then for mx, it's like I said, you always do 1/2 function squared, and once again, you subtract them because it's area between the curves. Then to find little m, which doesn't really look like a little m, it's going to be density times uh, 0 to 1, and I skipped that part. How is it 0 to 1? Because these two intersect at 1. You could figure that out by saying them equal to each other, or just by knowing that if you plug in 1 for both of these, you get the same answer for y, which is also 1. So they intersect at 1, 1. Um, but it's dx, so this is the one. This is the one that we care about, not to be too confusing. Um, so, anyways. It's just the function. Now, since it's two functions that are area in between a curve, you have to do this instead this time. So, and once again, the answers aren't shown what you get for these, but basically you would just still do the same thing. My divided by m would get you 9/20th. Mx divided by m would also get you 9/20th. That's what the answer would be. And notice that all of these have the density, so that cancels out. So remember what I said about that. You might think you just don't need to know the density. You don't for finding the centroid, but if you only needed to know mx, my, or m, you know it. So once again, the steps for these kinds of questions, the centroid ones, is find my, find mx, find little m, then you can find the x bar, y bar. This is probably a way more straightforward concept than we've had in calculus, so hopefully this is not so hard to you because, in my opinion, it's one of the easiest things. So, thanks for watching.